So let us try to finally understand what this Bayes theorem is. This is the last portion of this chapter. The understanding that you develop from here, it will help you really when you a lot when you solve problems. So this Bayes theorem is coming from the idea that you have a sample space in which you have these events A1, A2, A3, A4, so on up to AN, which are all mutually exclusive and exhaustive, right? So all of them are disjoint with each other. So if A1 happens, none of A2, A3, A4 or anything other than A1 can't happen. If A4 happens, anything other than A4 can't happen, right? They're all disjoint with each other, mutually disjoint, and they make up your entire sample space. Now, in this, if I have a unique event A, which is covering sum of A1, sum of A2, sum of A3, sum of AN, right? So it's covering a lot of events, but it is a very weird sort of an intersection of all these events, right? This portion of the sample space. Now, what I need is, the happening of an event AK given that A has happened. That is what Bayes theorem means. So AK is basically anything. It can be either your A1 or your A2 or your A3, right? Anything it can be. Now, I don't want all of this. What I want is, for instance, I can want what is the happening of A4 given that A has happened. So, this is your sample space. In this you have a lot of events which are mutually exclusive. In this you have your A4. Now there is this event called A which is covering a lot of these events, right? You need to find this portion. Because you need to see, you need to understand that A has already happened. Now what is the probability that A4 is also happening? That is what conditional probability means, right? So before coming to this formula, let us look at the formula that we already know. This is AK slash A, right? The formula is this. We know by conditional probability already. So I need the portion of AK with A. So right now, for convenience sake, what I'm assuming is my AK is A4, right? I'm assuming that. So just for the understanding point of view. So what I need is P of A4 intersection A divided by P of A. So I need the portion of A4 which is common with A, that is this portion. But now my sample space, the denominator, my sample space is now PA. My sample space is not the entire original sample space. The sample space for my given condition has changed to this pink region, right? So this pink region, it is a combination of lot of things. So how do I construct this A? So basically this A can be written as A intersection A1 plus A intersection A2 plus so on A intersection AN, right? So basically what I'm doing is I'm taking up this region A, taking its intersection with A1 which is this part, its intersection with A2 which is this part, with A3 which is this part. Likewise, I will take its intersection with all the regions, with all the AKs, with all the A or with all the AIs, I will take its intersection up to AN. So if it's covering AN, and I'll add them up. So if I take its intersection with everything and add them up, I'll be able to get this back. I'll be able to get this A, right? That is what I've done. Now simply because your A1, they're all independent events, you can simply do this. P of A is equals to sigma P of A intersection AI, where I runs from 1 to n, right? I runs from 1 to n. And if I divide with P of AI, this particular expression, and multiply with P of AI, right? So I'm just multiplying and dividing, then this portion of your formula, it becomes P of A slash AI. That means happening of A given that AI has happened. Just expand this using the conditional probability formula, P of A slash AI by P of AI, right? That's what I'm calling this part as this. So if I replace P of A, then it will be sigma I is equals to 1 to n P of A slash AI into P of AI. And that is what this formula is actually. So in fact, here also in the numerator, if I divide with P of AK and multiply with P of AK, I'll be able to get this part, right? And denominator I've already shown you. So this is what your Bayes theorem is. This is what the formula is. So if you just do a couple of questions where you understand like verbally how to read the question, pick up the information and interpret the information in a right manner, right? So a lot of times what happens is while solving problems, you commit this mistake where you assume AK to be A and A to be AK, right? You intermix because you're not able to read the data and take out the right information. You're not able to differentiate between what is your AK, what is your A. So what becomes the most important is to define events, right? So whenever you pick up formulas, be very clear in what your event is. In fact, write it like this. For example, event E is something according to your question. Event E1 is something, right? Write the events like that and then verbally say you want AK to happen when A will happen, right? A has already happened, and now given that A has happened, you want to find what is the probability that AK will happen, right? So when you say things and pick up the right information and use the formula rightly, you'll go right. So I hope you have understood what is happening in Bayes theorem. You're actually from a big region, you're picking up a region which is common to a lot of regions, and from that given region you're picking up an even smaller region and finding its probability given that this region, pink region, has happened, right? That is what your Bayes theorem is. So just when you do a couple of problems, it will be very clear. It's not very difficult. Sometimes it gets slightly confusing, that is the only part, but practice will actually help you a lot. So with this, we complete all the theory that was related to probability. I hope you found it informative and enjoyed the session.